All right, I'm going to get started, and as other people trickle in, they should be able to pick up as we go. So, manufacturers and Industry 4.0, how to get started. Thanks very much for joining this webinar. This is actually an updated take on a webinar that we did on this topic back last September. And it's the first part in a 4-part series of webinars over the summer. If you've been invited to this webinar, you should have also been invited to the other 3 webinars. We're going to be talking about predictive maintenance and some projects that are really interesting with that, using paper under glass for quality, and also OPC-UA compatibility. So watch for those invites in your inbox moving forward. But today we're going to lay the groundwork by talking about Industry 4.0 and how you can get started with that. So thanks very much for joining me. My name is Jared Evans. I have been working as an industrial engineer since graduating from University of Waterloo. I've worked as an engineering hardware manager at Apple, as well as in program management at Broadcom, making Wi-Fi and Bluetooth combo chips. Now I'm a co-founder at MAJK Systems. We make production monitoring and factory analytics software for manufacturers in the consumer packaged goods, automotive, and industrial supply industries. I focus mainly on customer delivery and field applications, as well as product management. And I also serve in the MT Connect Technical Advisory Group, which is an open source protocol for connecting machine tools over Ethernet connections. If you want to get in touch with me, you can email me at jevans@majk.io, or you can head over to our website anytime, www.majk.io, and you can view case studies, more about our platform, and also some of the different services that we offer. What I'm hoping you'll take away from this talk is first the state of the industry with regards to Industry 4.0 in manufacturing, the opportunities, challenges, and results that we're currently seeing in the market, as well as key questions to answer about your organization's Industry 4.0 strategy. From this, we'll talk about building a framework for implementing your Industry 4.0 roadmap, and I hope to also sprinkle in some additional knowledge about industrial networks, protocols, and security, how to get buy-in from your team, and also a little bit about manufacturing data analysis for continuous improvement. That will be much more expanded on in the next 3 webinars that we do over the summer as well. First, I want to quickly get us all on the same level with what Industry 4.0 is and what it promises. So Industry 4.0 is supposed to technically mean the 4th industrial revolution. As you can see on this graphic, it's about connecting all areas of your factory so that they can intercommunicate and have sort of ubiquitous connectivity through the factory. This will lead to streamlined automation, increased capacity for customization of products, ability to make adjustments in real time to meet production demands, and also imbuing even the smallest devices with intelligence on the plant floor. So what does this mean in the real world, though? BDC, the Business Development Bank of Canada, did a very interesting study and white paper about a year ago called Industry 4.0, The New Industrial Revolution. And it was subtitled, Are Canadian Manufacturers Ready? Now, the statistics that they found were based on interviewing about 1,000 different manufacturers in Canada. I think that these findings actually translate well to all of North America and potentially also Europe, just by my sort of understanding being in the market itself. Now, what they found was that about 40% of manufacturers have tried some sort of Industry 4.0 project, but only 3% are fully implemented. However, the adopters of Industry 4.0 are twice as likely to have 10% year-over-year revenue growth than their either competitors or other members of their cohort who had not. I've definitely seen that as well. I'd count our customers in that 3% of fully implemented Industry 4.0 players, and we've seen some excellent results with them as they've been growing their businesses based off of what they can do with data off of their plant floor in real time. You can go to our website to download case studies based off of that if you're interested. DDC found that the average project cost is about $250,000 over 2 years. This included costs such as employee salaries, contractors, hardware, networking, software, all kinds of things. So it is a big price tag potentially for some manufacturers, but it also entails a lot of different things to get a full project off the ground. From that, though, you can see that the top challenges that manufacturers face were finding skilled employees and then also unclear benefits. What I'm hoping to do today with finding sort of our roadmap for Industry 4.0 is to help you make the connection between that project cost and how that's going to impact you with that, say, 10% year-over-year revenue growth, and be able to really clearly define the benefits and the stages that you're going to have to go through to get those benefits. Diving a little bit deeper into this study, it's actually 39% of small and mid-sized manufacturers implementing Industry 4.0 projects. This leaves about almost 50% that really haven't done anything yet. And then when we look at Ontario, where I'm from, it's right on the average, as well as food and beverage, which MAJK works in a lot, is well below the average. So there's a lot of opportunity for early adopters in this market to get significant gains if they start working on Industry 4.0. Thing is that you've probably found it interesting what you've heard about Industry 4.0 so far, but there's a little bit of a disconnect between what's been presented to you and the promises that have been made and what you see day to day on your factory floor. Like, some of the promises made by it almost sound too good to be true, such as productivity increases, ubiquitous computing on the plant floor, like I mentioned. Not that these are necessarily unachievable, but you have to think that the timelines involved are almost too far out for us to worry about in our day-to-day operations. More and more we're seeing that that's just not true, however. If you look at some of the government initiatives going on, a lot of them are targeting the next few years to really make strides forward with this. Germany, who actually coined the term Industry 4.0, they've been working on a massive collaboration between government, manufacturers, and automation providers, with lots of funds going towards making these partnerships work. And they're targeting, after starting in 2013, to have this program really culminate in 2020. Similarly, the Made in China 2025 program is a huge push by the Chinese government to ensure that China is no longer just the cheap goods manufacturer for the West, and instead will become known as a leader in quality advanced manufacturing around the world. Its goal date is right in the title, 2025. They're trying to make a massive shift right now all over the country to bring that to fruition. North America, currently, the biggest push is IIoT, or the Industrial Internet of Things. This is more industry leading the changes to manufacturing with the government supporting initiatives. This has changed very recently in Canada, though, with the announcement of the Advanced Manufacturing Supercluster in Southern Ontario. We're one of the founding startup members. It's bringing together educational institutions, startups, large manufacturers, and also non-governmental organizations to lead the charge, allocating and supporting funds up to $250 million to become a leader in advanced manufacturing in the world. So you can see, though, with all of these, this is coming sooner rather than later. And again, I would strive to say that the early adopters are really the ones that are going to be getting big opportunities. But it doesn't happen overnight, and that's why I think it's very important to set up your roadmap document for how you're going to affect this change within your organization. Last point on the BDC study, they had some great findings at the end of their report for key strategies for making the digital shift. First was focus on customer needs. One of the key benefits of digital technologies is an enhanced capacity to deliver value to your customers. If you start by striving to understand what your customers currently find valuable about your products, you'll be able to discover their true motivations for buying from you. And then you can find digital technology that will help you increase that value. Second is be strategic. It's important to evaluate your current digital maturity, decide where you need to be in the coming years, and then make a plan to get there. That's that roadmap that we're talking about. I'd also lump into this, don't focus on a specific technology. It's often much more valuable to integrate your technology implementation plan into a broader sort of productivity plan within your organization. Technology should be a tool for this, not a goal for this, I guess is what I'm trying to say with that. Next, they really said empower your employees. It's very important to be able to share your vision with your employees to make them understand why you're undergoing these changes within your organization. And also from that, work to retain talented employees, provide more training on new technologies, and also sharing the success with everyone. Their fourth point was walk before you run. That's a real push with MAJK as well. We do lots of pilots early on with customers. We have a quick start program just starting up to allow you to get moving with these type of projects with a small overhead and really quick implementation time. So how does that look as you really dive into a project like this though? Starts off with your customer, really focusing on their needs. That'll allow you to figure out how that maps to your value and drive your project success. When you look at your customer, they often have a lot of needs. They'll say that they need higher quality from you, maybe more products produced, lower cost of production, or traceability through your production process. Often that can be masking even more detailed issues that they have, such as do they actually need just more product produced overall in general, or do they need it delivered at a certain time? Or with lower cost of production, is that just for one flagship part that they sell from you, or is it for multiple configurations and styles? Once you understand those type of answers, you can really start figuring out how your value impacts that and double down on what you do for, again, that project success. That's really made by your employees, understanding how they can contribute to that value and giving them opportunities to use data and digital manufacturing to do so, and allowing them to be successful within their project roles. I also think that it's very important to look at project success on terms of immediate, short-term, and long-term. We see often in projects like this, especially say homegrown projects or out of something where manufacturers are just using some sort of out-of-the-box software, you often get immediate gains in your project by just putting up, say, a TV with where you're at with the production schedule. You'll get a bump in production. But does that translate to long-term improvement, or does it drop off after a few months? And that's really what you want to be making sure that you're driving is long-term improvement as well as immediate and short-term. So when we talk about that, really the execution stage is disseminating the strategy to your employees. And I think the best way to do that is a written roadmap document. I think these type of documents are superior because they create consistency across your entire team. They're more lasting, and it also raises accountability. You can always go back to that document to say, here's what we we're committing to, are we still meeting those goals? And you really want to align it with your company's goals. If there's certain initiatives for higher quality or reduced cost per goods sold, or other initiatives that your company has, aligning your Industry 4.0 roadmap with that will definitely make sure that the projects deliver value right away and move forward. From there, you can work on getting your stakeholders on board. So what's required in an Industry 4.0 roadmap document? I think 5 main areas are. First is the employees and what roles you're going to require for the project. Second is your stages of implementation, so selecting a pilot site and how you plan on an organizational rollout with this. Third is your connectivity strategy. Any Industry 4.0 project is going to require connecting to your factory assets on the plant floor. So you don't have to have it perfectly flushed out from the start, but you do need to know roughly what you want your network architecture to be, or have an idea of how you're going to solve that. And then also how you're going to deal with networking and communication protocols. I'll give you enough knowledge to be dangerous on that later on in this presentation. So if you're unsure of that for right now, that's okay. You can even get through the pilot stage really without worrying about that too much. Fourth is security considerations. I think it's very important to build security into your plan from the start. Nothing's worse than building something and then realizing that it's inherently insecure by the way that it was built. So it's good to go through a little bit of threat analysis and thinking about security strategy, which again, I will give you a quick primer on that later in this presentation. Fifth really is using the data that you collect. So like I said, how are you going to define your immediate short-term and long-term benefits? And also knowing your users. How is this going to affect different groups of people within your plant and outside of your plant once you start having data? So first off, employees and roles required. Back to this DDC study, they looked at what manufacturers thought the biggest challenges in implementing Industry 4.0 solutions were. And at first when I looked at this list, I was very surprised. MAJK actually usually lives down near the bottom of this list effectively, is when you look at meaningful data analysis, cybersecurity, data integration, that's all products and services that we provide to our customers. So that's where I sort of live on my day-to-day, is solving those problems. So it was really eye-opening to me to see that that was actually low on the list for manufacturers, because they were having to get through all these other issues above that before they could even start on the problems that we solve. So like I said, those are sort of implementation problems. Versus right at the top, lack of qualified employees. That's a personnel problem. Excessive costs, unclear return on investment, employee resistance to change, financing, technology's complexity really boils down to a personnel problem, because every technology is built by people. It's just, do you have the right people to be able to work with those technologies to bring them to a useful state within your organization? Then difficulty knowing where to start. That's sort of both a money and people problem, depending on the personnel and different plants that you have, budget you have, all of that, right? So when it really comes down to it, most of the problems that you have to solve to get this off the ground boil down to either personnel or money problems, right? So on the personnel side, you really need to make sure that you align your employees and contractors' success with your project goals, and that will allow you to justify the costs. When I look at that, I think of sort of 3 levels of solutions in your plant. First is a pilot solution. Second is a subsystem solution. Third is a full implementation. Really for a pilot, at least with MAJK, what we look at is we really only need like an automation provider or somebody who understands the operational technology side, like the PLCs and CNCs and controls on your plant. So that can be somebody like us, or that can be somebody that you already work with your PLCs, or even an internal employee who has taken that on. Then somebody like a production or line supervisor who's going to be using software like this on a day-to-day basis to make improvements on the plant floor. And then a project champion, which really should be you or delegated to somebody that you really focus on or really trust closely to make the project a success. So finding 3 people or 3 groups like that usually is within the wheelhouse of anybody within, say, a single manufacturing plant or something like that. So once you get up to subsystem solutions, whether that's for a full department or a full factory, a single factory within your plant network, you need to start to take into account department stakeholders like quality assurance, operations, maintenance. It might be a good time at this point to also bring in a project manager who can make sure that things stay on schedule, is good with working with outside vendors, etc. At this point, I think you actually want a controls or automation expert internally working with this. In the pilot stage, you can outsource that to either a software company like us or a automation provider that works on a consultative basis for you. At this point, you need some of that expertise internally. You also need to involve your IT team or a plant networking specialist. You're starting to deal with probably firewalls, your plant network versus your office network, and you really want to make sure that you're doing the right thing so you don't overload your network or do something that's going to cause you issues down the line. Once you get to a full system implementation, obviously you're going to need executive buy-in. Now we're starting to talk about those $250,000 type project costs, so you're probably going to have to go up the chain to get things approved. You're probably actually going to want to potentially outsource again to find an automation industry expert that can tell you not just how individual PLCs can interact on the network, but how they can all interact together. You might even want to consider upgrading your project manager status up to program manager, somebody who can manage multiple projects at once and bring them together to have a common goal. At this point, you also want to be working on data analysis and looking at trends throughout your data across plants, on different machines, on machines from the same vendor, all kinds of sort of higher order data investigations. And at this point too, we often see the next logical stage is connecting all this data from your plant floor up to your ERP system to help drive business initiatives as well. So you're going to need to involve that team too. So stages of implementation. Really, this starts off with, as we were talking about, sort of that pilot phase, subsystem, or single plant phase, and then full implementation. Big part of this is sort of choosing facilities. And at the start, you really want to choose a facility that is going to lean you towards a successful project. And this simple diagram is actually a very interesting decision-making tool for me anyway. This is actually created by Volkswagen. This is how they decide where to invest in more automation in their facilities across the world. It was presented in a paper and a case study actually for the World Congress of Engineering in 2007. Their sort of thesis out of this is that as automation within a facility increases, you need less personnel to make the same amount of product. But once you get up towards, say, 70, 80, 90% automation, increasing automation by another 10% is dramatically more expensive. Labor costs, on the other hand, decrease linearly as more automation is introduced because you're effectively having less people work on each product, and that reduces labor in a stepwise manner. So what you're really trying to do is find an optimum between labor and automation costs to drive your cost per unit of production down as much as possible. So to me, that has a very good allegory with the Industry 4.0 projects. It's not so much that you're going to be reducing personnel costs with every stage of this. It's often allowing people to either be more effective or to work on larger problems that move your manufacturing ahead. But the same idea is consistent, is that you want to find a place that already has a decent enough amount of automation that you can get a project off the ground fairly quickly. And also you want to look for an area that will help you either minimize your total costs or maximize your total profits based off of sort of these two parameters. So when you're selecting a pilot site, I think some other considerations I know firsthand are you really want to make sure that there's engaged employees at the pilot site and that you have the roles that we discussed covered for those initial pilots or small scale implementations. You also want to identify a solvable problem for the scale of the pilot. You really don't want to be going into, say, a $5,000 pilot thinking that you're going to solve all your manufacturing problems. $5,000 pilot maybe gets you a productivity increase on a single line in your plant, or it helps you root cause a pesky downtime that you didn't realize about, or it helps you put more pressure on your suppliers to deliver you higher quality parts because you can show through traceability that that's where some of your quality issues are coming from. You also want to identify measurable goals off the bat with the pilot and create a timeline and a mechanism to say, if we hit these goals within this time frame, we are going to be moving forward with larger projects on that time frame. So we talked about this at the start, that $250,000 number. The study from the BDC, actually, when you dive into it, has a $261,000, average investment in Industry 4.0 over the last 2 years for manufacturers who did work on Industry 4.0 projects. Interesting thing that is also in the study is that the manufacturers who spent more on their projects rated their projects as doing better. So obviously, as a vendor in this space, I may sort of lose a little bit of credibility when I'm talking about spend more money and you have a better project, but what I do really see is that it's more about commitment. It's about if you're you as a manufacturer are committed to seeing a project through and seeing benefits, you're most likely understanding that you're going to have to spend more for a good solution. But that means that everything's aligned on that. And really for any of these dollar amounts that we're talking about, as long as you have a path to get that return on investment, which comes back to having those immediate short-term and long-term goals for the project, and you make your investment in stages, you can really reduce the risk of these projects, and you can also make sure that you're holding your vendors accountable, making sure that your employees are understanding whether the project's on track or not, and then allowing everybody to share in the success when it is successful. So now we're going to get a little bit more into some of the technical areas of this. Like I said, this is still just going to be a broad overview, but I think it is enough to sort of make you dangerous when you go back to building your Industry 4.0 roadmap and asking the right questions of your different teams. I'm going to try to move through this fairly quickly though, because we will be talking more about this in our subsequent webinars. But I will still try to give you enough information that it's a good takeaway for you. So first I'm going to talk about some of the different network architectures that we see. And I really think that this is just the main question that you want to answer for your pilot stage or your roadmap is what type of network are we going to use? Some people use single networks for their entire facility. That means everything including the PLCs, CNCs, office network like printers, mobile phones, computers is all on the same network. They can all ping each other with IP addresses on the same subnet. Benefits of that are it's really easy to communicate between computers, servers, and industrial equipment on your network. It's faster to set up networked applications such as a manufacturing execution system. You don't really require any extra permissions from an IT perspective, but it is easier for intrusions on your office network to affect your manufacturing. And it's really up to each individual device maker or installer that gets added to the network to configure security locally on that device to a level that will protect it from attacks. Then you really need to have strong IT policies in place to mitigate. Sorry about this. I'm getting an update from Microsoft. No, thank you. To mitigate threat risks from individual devices on the network. So I don't really recommend a single network for your entire facility. It can help you get moving very quickly, but it's not going to scale for your overall implementation. One that we often see, especially in consumer packaged goods, is the plant network and office networks being separate with a mediator between them. Either that can be a software firewall or an actual hardware switch and router type firewall. Benefits of this are it allows required communications between the office and plant network, but the industrial networks are secure from unauthorized intrusions as well as office network traffic. This does limit the application access to PLCs and other industrial equipment, which is a bonus. And it's also still fairly fast to set up and work with while maintaining security. Some of the issues with it, though, are that it requires a managed set of rules to maintain the firewall. And in my experience, anyway, people will ask for exceptions to the rules. And at that point, you need to decide who will grant that access, who gets the final say of what's allowed through the firewall. Is that your IT team? Is that your operations team, et cetera, et cetera? Also, it does still allow direct connections between plant and office networks. So if an office device connected to a plant device is compromised, that could potentially allow access to the rest of your plant network. Usually in consumer packaged goods, that's not a huge issue. You're maybe talking about, say, one machine going down when it's not supposed to. If that's a bottleneck machine or a machine that costs a lot to get started again, like we see sometimes in automotive, that's where you run into some higher risk on this type of network design. Which brings us to the third type of network, is the separate plant and office networks with a demilitarized zone in between. This is really popular in automotive right now. It allows brokered communication between plant network and office network through applications running in the demilitarized zone. Industrial networks are secure from unauthorized intrusions as well as office network traffic. And it pretty much completely locks down access to PLCs and other industrial equipment from the office network. So it does make it more difficult to implement and update applications and gives you a lot less flexibility in your networking, but it is sort of the better overall solution when you have a lot of critical equipment within a network. And also if you're connecting, say, hundreds of pieces of equipment to the network. From this, industrial networking protocols, I know there's just so many out there. There's legacy ones, there's newer ones. Really, as long as you're working with vendors who can talk with these type of protocols, we talk with all of these protocols plus more. That will really get you where you need to go in this space. A lot of legacy equipment uses things like Modbus or S7. Newer protocols like Ethernet IP or EtherCAT are coming in. You just want to make sure that for what you have in your plant, the vendors that you choose can work with that and also have solutions to go through the upgrade phase with that as well. Top of that, there's industrial communication protocols. There's a lot of buzz around OPC-UA for interconnectivity within the plant. And then I talked about MT Connect as well. They're really about transporting data once they've been taken, that data has been taken off of a PLC. Again, I would just stress you should be choosing vendors and solutions that are compatible with this. And then if you have legacy equipment that's not compatible with it, find vendors that can make it compatible with that. And that'll actually be the subject of our 4th webinar in August this year. So like I was alluding to, what's the right protocol to choose? Really, it's almost whatever gets the job done. It's usually better to standardize on one industrial networking protocol if you can, but different communications protocols and also software packages can fill the gaps and mismatches in your plant. I recently read something like the average industrial equipment on a plant floor in North America, I think, has about a 30-year lifespan. So on average, we see equipment that's, say, halfway through that life cycle. It's not worth pulling out a piece of equipment just because it has the wrong protocol or something like that for what you're trying to move forward with. You just want to make sure that the equipment that you do move forward with can speak protocols that work with your system. And then also that you have software and solutions that fill in those communication protocols. You also want to be realistic. Choosing an automation provider that can work with multiple protocols, like I said, is very important, including those legacy protocols. For cybersecurity, I think the biggest thing is to understand why do people want to attack you, or that's at least the most important thing to put in your Industry 4.0 roadmap and think about from the start. There's a lot of reasons why people want to attack corporations or sites with industrial networks. Sometimes it can be a good jumping off point to your larger network. It's often easier to compromise industrial equipment than, say, a server or something like that. Usually your IT team is monitoring all your outward-facing servers. You need Microsoft OnePass or Active Directory access to access those. There's well-known procedures for deterring attackers versus industrial protocols are a bit more, and industrial networks are a little bit more of a Wild West. Also, just having access to control systems. People find control systems very interesting, whether it's for monetary gain or just for trying to hack it, and it'll be it puts you as a bigger target. Sabotage can always be potential, as well as access to data. You have to think, how important is my data? If your data just shows even how much of a product you're making, that can be, if you're a public company, that can be very important for either your competitors or people trying to decide whether to buy your stock or not, all kinds of things. It can also be internal blame shifting. If people know that within your organization know that something's wrong, if they can shift that blame somewhere, that might be a reason for an internal attack on your network as well. And in case you thought this isn't a huge problem, I went to Shodan.io, which is a search engine for connected devices on the internet, and I searched Allen Bradley. I got about 5,000 results of PLCs that are just on public IP addresses connected to the internet right now. So all of those PLCs are potentially open for an attack, depending on whether they have local security set up or not. But that really gives you an idea of how prevalent this is and how little security our industry is really standardizing on in the current at the current time. So I talk about a security strategy sort of in 5 layers. First is prevent, second is detect, deflect, deter, and then recover. I'll just quickly go through these because I think it is important to, in your Industry 4.0 roadmap, figure out, or at least put in the heading for each of these of how you're going to do them. A lot of people just look at prevent and detect. They don't go into the final 3, and I think that is something that we can do better as an industry. Prevention, to me, is basically impossible. Not to say you shouldn't try to prevent things. It's just that the higher profile your organization is, the more likely you are to be targeted by a bad player within or outside of your organization. And there's really just too many layers and loopholes at this point to make a perfectly secure organization. You need outside contractors. You need to be connected to the internet for your business to function. So you still need to work hard to consistently improve and complete your threat analysis, but you can't just look at prevention as the only thing that you're going to do to make sure that you keep everything secure. So that's where we go to deterring attacks. I would like to talk about sort of a bike lock analogy. No bike lock is impossible to break. What it is it's how long it takes to break, right? If you get a really good bike lock, it might take a thief all day to break into it. At that point, hopefully you've come back for your bike or somebody's seen them as they've been trying to break it for the last 8 hours. So you want to have authentication. Often 2-factor authentication is better if you can. You want to keep all your software up to date and also patch easy access points. Then we get into sort of the more detailed layers of security. So deflection. So you want to make your organization less of a target. It's sort of that old joke about going camping. You don't need to be faster than the bear. You just need to be faster than the slowest person that you're camping with, right? So some things that work against you on that are if you have a high corporate profile, so like if you're a public company or you're really in the news a lot, or if you have valuable data, whether that's, say, proprietary bill of materials or work recipes or information that might affect your stock price, that type of thing. Also, access to control systems, again, is a big determinant for people wanting to infiltrate your network. Fourth is detection. So how do you detect when you've had an intrusion? Or would you always detect if you've had an intrusion? This places a lot of push on your IT team to make sure that there's activity logs within your system and also potentially checkpoints with users, sort of like your credit card company does. If they call you up and say, do you take a charge at Walmart on such and such a date, allows them to make sure that you're not compromised. You can do the same thing within your systems and your employees as well. And that also goes hand in hand with system monitoring. And then assuming that eventually you will have some sort of intrusion on your network, you should really be thinking of your recovery strategy. How easy is it to recover from a data breach? Say you needed every user within your company to change their passwords, or you needed to update every plant network firewall within a certain event. How fast could you do that? How can you mitigate the cost of losing data? And then how can you regain trust internally and externally? Again, these aren't things that you need to have worked out for when you're doing a pilot with Industry 4.0 technologies, but I think it's important to put into your Industry 4.0 roadmap, because these type of questions will get asked by your IT team, by your CIO, by the leadership of your company as you try to move this forward and get that executive buy-in and buy-in from other teams. You do need to have answers to, or at least starting points to talk about what you think will work for these different situations. So finally, I'm going to quickly go through a bit of manufacturing data analysis, and then I'll try to cap this off within the hour. Like I said, to use the data you collect, you really want to look at immediate, short-term, and long-term goals. We see a lot with immediate goals, driving worker engagement and reducing time and money spent on data collection are big asks from people starting these projects. And then in the short term, they want to increase a performance metric, such as OEE. There's lots of studies going around about how implementing a production monitoring system can increase your OEE by as much as 20% just by having boards up. Where we really see that is as you build consensus across a team, it allows you to really have the team drive all on the same problem. Oftentimes, before we come in, we see maintenance working furiously to try to fix problems by maintaining equipment more effectively and better, spending more on spare parts, that type of thing. Well, production in parallel is also working to get more product out the door using the tools they have available. If you can get those two teams working off of the same data set, you'll be surprised how much they can work together to solve the biggest problems first and then move on from there. Long term, you can use data that you collect for detailed audits, forecasting, capital equipment decisions. So do we buy another machine, or do we get more capacity out of the machines that we already have? And then really building a culture around metrics-based performance and decision-making, I think, is really the biggest push for all of this. The benefits out of this, again, according to BDC, where 60% of adopters say digital technologies boosted their productivity. Almost 50% saved operating costs, 42% improved their overall product quality. And then I think this fourth point is very important, 13%, and I hope that this will get higher in the future as people do more of these projects, identified a greater capacity to innovate as a benefit. So if you have more time on your line, you can maybe try an experimental product run. Or if you free up time from just pure data collection from your team can spend more time analyzing data to figure out what the best next project is. Looking at different user groups across your organization, I think it's very important to take all of these into account and how a project in the Industry 4.0 space will affect each group, because it will change each group's job description and allow them to make different decisions, and also they should have a seat at the table as these larger projects get running. I'll just skip through this quickly. What I'm talking about is different needs from different groups. So we often see from the production team, they really want to know whether they're on schedule or not. And they want to eliminate spending time on finding information and have more time actually using information. So that's what you want to deliver to them to get them on board. For logistics and operations, a lot of it is about supplier and customer management. If you can tell a customer, say that you're going to be late, but you tell them 2 weeks in advance so they can adjust their schedule, that makes you look like a hero rather than a villain, right? So Real-time production attainment metrics are huge for logistics and operations. Having a reference point for production meetings and data visibility across departments is very important. And also integration with ERP systems is a big deal, so you can start automating some of the procurement and things like that. Maintenance. We see more and more the biggest push is root causing downtime. We sometimes talk with maintenance teams, and we find that they almost get stuck in a trap, almost like paying off one credit card with another. They're running around trying to fix different issues time and time again, fixing the same issues because they can't spend the time getting down to a root cause of what's going on. So easy to use interfaces, being able to drill down, getting notified by text or email about downtimes, all really big things that maintenance looks for. Quality assurance, being able to dive into those SPC measurements, scrap and quality tracking, all very important. And then your IT or IS teams, they really want third-party systems that work with their existing technology and network architecture. So we were talking about those network architectures previously. It's not necessarily so much what network architecture you have. You just want to make sure that you're working with teams that all agree on the same network architecture, or you're working with vendors that can provide connectivity over those network architectures. It's also nice to have a single point of contact for project management, maintenance, and customer support for your IT team. They don't really want to be dealing with any like having to phone different people if certain different parts of your system breaks, that type of thing. And so I think that's really where you get the buy-in from IT if you can deliver on those issues. So just to recap, what I'm hoping you got out of this for your Industry 4.0 roadmap document is you have an idea of the roles required for employees that you need at different stages of your implementation. And I'll leave it to you to flesh out in your organization how you would go through those different stages of implementation. You should also be able to identify what type of network you have and get questions answered from your plant teams about what networking protocols could be used for data collection. And then I would also say that moving forward, you want those security considerations in the document to be answered as you move forward with the project. And then you should have sort of as that carrot for all the different teams involved, how using the data you can collect can help each of them with their jobs. This slide got a little squished, but obviously Tesla hasn't been doing quite as well as they were hoping with some of their manufacturing hell that they've been going through. But I do think that understanding your factory and understanding how you can optimize it is really a very important point. And we're really just getting to that point today where IoT technology and cloud computing and data streaming, all the new technologies that are coming out of the tech sector can really start helping manufacturing to get us through this Industry 4.0 fourth industrial revolution that we're just on the cusp of right now. And as Peter Drucker said way back in the early 1900s, if you can't measure it, you can't improve it. And I think that's really the basis of Industry 4.0. There's lots of amazing things that you can do with it, but at the very basic level, we're really extending those ideas of the first sort of management sciences and industrial revolution, is that you need to start understanding where your production is, how it's running, what's affecting it. And now with the plethora of sensors and data that can be captured off the production floor, we've never been in a better position to do so. So I hope you found this webinar interesting and informative. If you want help going through building your own Industry 4.0 roadmap, you can definitely connect you with a field application specialist at MAJK Systems who does so. So just please contact us afterwards. Otherwise, thanks very much for your time.